First of all, let me give the obligatory couple of slides about the Dow Chemical Company. I've worked for the Dow Chemical Company basically my entire career. Someone at the table asked how long that was. I was joking about I've been at this a very long time, and come June it'll be 36 years, so longer than I haven't worked at Dow, put it that way. Our company's been around, as you can see on the slide, for a little over 100 years. And you've probably heard of us. I'm not going to go through all of the details, but basically, global company, lots of products, 50,000 employees. This is an eye chart, but it gives you a bit of and you can read it in your materials. It just gives you a sort of a 50,000-foot view of the company and the various things that we are involved with and the products that we make. The name notwithstanding, we are much more than a chemical company. We now are into everything from automotive subassemblies to diesel fuel filters to solar shingles to you name it. So it's not exactly your father's Oldsmobile anymore or your father's wet chemical company. So the request that we were given as speakers and asked to talk about this is taken verbatim out of the email that I got, is to look at the current state of the ISA Level 3 application. Well, you can read it. I'm not going to read it to you. But basically, what are some of the issues? What are you doing to address those issues? Where are you? It's a journey, a long journey in some cases. How do you get there? How did you get there? And I'll talk a little bit about how we got where we are, maybe some of the false starts that we've had along the way, and what are we doing about the situation. So, without further ado, I've spoken at several of these conferences in the past, and if you've heard me speak before, I apologize if I'm going to repeat myself a little bit. I promise not to take you down memory lane, but it is important to understand a little bit of the context because we are coming at this thing from a little bit different perspective than maybe some other companies. This phrase, the catchphrase that you hear, shop floor to top floor, I don't know who originally coined that, but we were doing that and have done that for quite a long time with one very large caveat. We did it basically exclusively with proprietary software and technology based on what is now really pretty old skunky hardware and infrastructure. If you're not familiar with the technology, that upper right-hand corner is a VAX 11780. Circa 1978, and then down at the lower right-hand side of the screen, you'll see, your proverbial IBM green screen. And I picked those pictures because the systems that we developed back in the 80s were based on that technology. Mid to late 80s, early 90s, we were pretty successful in implementing that and integrating our enterprise system all the way down to our control system. No good deed goes unpunished. And so the punishment comes a generation later that we have this stuff in place even today. We have probably, I don't know how many, but I'm certain one of the largest concentrations of VAX and BMS computers still left out there. So our perspective is in a sense, crosses the domains of collaborative manufacturing integration and migration, which is also a major theme of this conference and has been in the past. So it's how do you not just get there, but how do you get there, sustain or improve what you have, and not take giant steps backwards. I think that's about it for that slide. As I said, there's still a lot of these out there in use. We've all seen this picture or pictures like it, the proverbial spaghetti diagram. And we all have seen probably how many, ad nauseum system integrators, consultants, otherwise, or other, very smart people talking about trying to avoid the spaghetti diagram and get some sort of, integration in a logical, coherent, cohesive way. One of the titles I carry in the company is System Architect for Manufacturing, and the good news is I'm not going to take you through this. You've probably heard it 1,000 times, but I just put it up there really to help set the context for some of my remarks. So, speaking of system architects, Let's take a look at what the world looks like to various constituents. As seen by a system architect, it's really not that tough. As a colleague of mine used to say, system architect's job is really easy. All you got to do is be able to draw cute, fancy diagrams on a whiteboard. It's very simple. You get it all drawn up there, and the lines go in all the right place, and do your proverbial equivalent of a mass and energy balance to make sure you don't have any dangling lines and so forth. And we've seen the diagrams out of the ISA 95 standards. And again, I'm being somewhat flippant. I'm not trying to denigrate the work of the standards. I've been involved in the 95 standard, for example, almost since its inception. And I can't denigrate ISA because I'm the Vice President-elect of Standards of ISA, so I take that role over next year. But the point I wanted to make here is the system architect sees things very conceptually. Now, it's very nice to draw these diagrams up here and say, oh, all the flows go in the right place and everything, but then you get to the reality of the situation, and this is what you find when you try to take that and put it on the ground. And I think many of us here have seen this, or something like this. Things are going every which way. And in our case, just to bring this down to something concrete, because I know I'm probably preaching to the choir, our experience in our company has been, I mentioned earlier, our history, our legacy is in proverbial wet chemistry, batch and continuous. We are, if you follow our company at all, have been making significant changes in our business portfolio, and we're getting into areas now that we're not really that comfortable with or used to. Discrete manufacturing, a lot of very complex operations that we're just not that, we just don't have a lot of history. So, when you get an engineer who's used to, in a sense, handling the information flows in the automation system for an ethylene plant that runs flat out for 7 years and never stops, and then you give him something like this, it's a bit of a shell shock situation. So that's challenge number one that we're facing. And I'm not going to stand up here and wave my hand and say we figured it out. It's a work in progress. And by the way, we didn't sell our ethylene business, so we've still got to do that too. So picking up on that theme, again, we're giving credit to the 95 committee, and I see some of the luminaries from the 95 world out there in the audience. Again, fairly simple diagram, right? Hierarchical model, level 3, 4, 4, 3, 2, 1, 0, all the way down. Now, our situation that we are faced with today, and this has been going on for some time, but it's gotten more complicated in the last, when did we close the deal on Roman Haas? 2008. It's gotten much more complicated, say, in the last 3 or 4 years, is that all of these levels are in motion at once. And so just to elaborate on that, we are in the process of uplifting our enterprise systems from SAP R2 to SAP R3, whatever the current version of that is, globally. So that's a huge task. In doing that, when we acquired Roman Haas, we brought in their SAP implementation and trying to rationalize that and harmonize that across the company. So that top layer is in motion. Big team of people. You can imagine SAP implementations are very large. Down at the bottom, and I'll come back to the middle in a moment, that's sort of our focus here today, is at the control system layer. We went from a uniform control system to a lot of diversity through mergers and acquisitions, some of which is getting fairly old and long in the tooth, and we have a very comprehensive migration program just getting off the ground. We've talked about it for years, but thank God it looks like we're finally getting serious about it, to move the control layer in a very fairly large, aggressive way. And then in the middle, the collaborative manufacturing space, MES space, manufacturing operations, whatever you want to call it, we have a program underway there that is trying to address the very divergent needs of everything from a solar shingles plant to a chlorine facility. And they're in no way the same. So think of these as 3 major programs, and if that isn't the definition of collaboration, I don't know what is. It's internal collaboration, and it's, as you can imagine, rather challenging. So the situation you find yourself in is that literally the ground is shifting beneath your feet. the people that are working in this space are finding that truths that they held self-evident, to take that quote, aren't anymore, and it's causing some fairly significant dislocations. And I don't really have much specific in the slides, but I'll try to touch on some of the examples of that as we go along. The biggest one is, I think the biggest one and most notable one that we're facing right now is that the people working on this, as I said, don't have a lot of practical experience in some of these different process types, and are working with what was formerly Roman Haas, a set of business people that don't share the same culture. And so it's, well, it's a challenge. The technology is not the challenge, not really. And that's why when you get the pitch from the systems integrators and the architects and the vendors and so forth, you can probably make this work with just about anybody's technology if you can figure out the culture and the people issues. So, some examples. You have to look at what we're doing. I shouldn't say you have to. The way we're approaching this is we're looking at first of all, systems capability. This is kind of system design 101. What are the requirements? What capabilities do you want? Write them down, categorize them, prioritize them, sort and sift them, and so on and so forth. And this is just these are just some examples. And I can't even read that from here, but hopefully you can. Whenever I give one of these talks, I never know whether to put my glasses on or not, because I use them for distance only, and I don't wear bifocals. So if I had my glasses on, I could see you, but I wouldn't be able to see anything on this table. Anyway, that's just an aside. But we've all seen this approach, right? So figure out what your capabilities are, break it down, do a functional decomposition. Looking at it on a landscape basis, as I said, our challenge is everything's in motion at once. So you start taking those capabilities and you start figuring out where they are and what the implications are, and they don't neatly fit into any one place because a decision that you make here may have implications way over here. So you end up with these kinds of diagrams. And then the other thing that we found, because of the diversity of the business types that we're talking about, is that the layers are squishy, is the best way I can put that. Think of them as compressible disks. The relative thickness of these layers varies by business type and by situation. And we're a big company around standards and trying to do things one way, and this is probably one of our biggest challenges, is trying to come up with a set of solutions. We've already rationalized or convinced ourselves it isn't one solution. That was a bridge too far. But a set of solutions that meets the variety of business needs with these different layers. So, for example, I mentioned ethylene earlier. In the ethylene business, it's all about control. There really isn't much at the MES layer, and you tell the ERP system once a month how much ethylene you've made this month, and that's about it. There's not a lot of interaction. I mean, I'm oversimplifying, but you get the idea. Other businesses, these thicknesses are much, much different. This is another way of looking at it, maybe drilling down a little bit more, is now you're not talking about businesses as much as process types. So process, proverbial continuous process, CPI kind of thing, and then discrete, and then something in between. And this is just a chart this came out of the project, the manufacturing execution project that we've got going on right now, where they basically are trying to figure out, of the process types, what are the relative importance of these attributes like integration, availability, agility, and so forth. And as you sit down and talk to people, you find out that the answers are different. And it makes fitting those solutions to a wide variety of situations that much more of a challenge. And I mentioned business type earlier. This chart just gives you some ideas or some examples. These are real examples out of our project of some of the things that people sat down and said, well, how do you characterize needs by business type? These are some of the things that you have to take a look at. And I have no idea how I'm doing for time, but that's fine. Anything really large, you have to have a program approach. This is probably no surprise to anybody here. And this is just, again, this slide comes right out of the package we use to promote this program with our management is to look at this from a program perspective. And if you remember the slide I showed earlier, the complexity now is that we have 3 programs going simultaneously, and trying to keep them synchronized is a huge challenge. And we do that, you know, I keep saying we've got all these challenges, I'm not telling you how we fix it. The challenge, that particular challenge we do with, as you can imagine, by a lot of cross-fertilization and involving people. And the other thing that we do is the principle that you can have 3 programs, but ultimately it all has to ride on one architecture. So people like myself, I lead a team of architects, and we get dragged into almost everything in order to make sure that it's consistent. Again, coordination, lots of communication, and I mentioned common architecture. Quick plug, I guess, for one of the things that people are always asking for is real case studies. Well, myself and some other people that are actually at this conference are working on a white paper right now specifically addressing this for the continuous, or the continuous process industries, the CPI. And it will hopefully come out shortly. We're waiting on the last case study. And the idea basically is to publish this thing so that people can see some real world case studies and hopefully use them as an example. And this gives you an idea of some of the case studies we have identified so far, and we're waiting for, what is that? That's 5. We're waiting for 1 more. And I think that's all I had. So very quick overview. No way in 20 minutes could I get into all the gory details of what we're doing, but hopefully we can get into some of that during the discussion period. Thank you.